So they're waiting for people. There are more people rolling in. So just 5 more minutes, and then we'll start. Refresh it. Sorry, bro. We are live again. So thank you everyone for joining us, taking out time in your busy day and on a working day. So we hope that it will be really interesting and you like it. So the stage is for Ankur. You begin the session for you. Thank you.
Hello guys, this is Uncut over here. I'm senior software engineer in Rental, and I'm like a cross-platform mobile app developer. And like I have key skills in like developing mobile app for Android, iPhone, using HTML5, and then JavaScript and other JavaScript frameworks like AngularJS, Backbone, right? So today we are over here to present a presentation on Android NDK. Okay, so let's make it very interactive session for today. I'll be asking lots of queries from you guys today. So the very first thing, Android app so far? Anyone in the hall? Yeah, sure. So how was your experience? I mean, how was your like you begin the developing app? I mean, what is the language you opted for, and what are the platform you've taken up?
I mostly use Java.
Okay.
I never really made any great apps. I just used the beginning NDK tutorials to make some, and then just demo apps.
Okay, so you must have used SDKs, and you must have used Java programming language, right? And okay, so one of the major ways to develop an Android app is make use of Java's SDK. I mean Android SDK, which is like dependent upon Java language. Okay, so this is one way. Though now another, we have few more ways to develop an Android app. The another approach is like you make a hybrid app using PhoneGap, right? And make use of your existing web skills, HTML5, JavaScript, and CSS, right? But that will be a hybrid app. That won't be a native app, right? So this is another approach. So now the third approach, which we'll be like doing over today, is by using Android NDK. So this is completely out of box thing. So when I say out of box, it's like we won't be using JavaScript, we won't be using Java, but we'll be making calls to C and C++ things, right? So just imagine from this point of view, like if you are making use of C, right? So imagine how much power you have in your hand. You have access to all the hardware, memory accesses, because C is a very, what do you call it, powerful language, right? So let's start off with okay. So we'll be like covering first of all like what exactly is NDK. So I'll invite Raman, my friend.
Good evening, everyone. I'm Raman Bedi. I'm a software engineer at Chandigarh. I like to work in HTML, JavaScript. I'm an avid follower of front-end frameworks. I like to program on Hadoop. Plus, I have interest in Java. And yeah, I'm a fan of Rails. So we would be going further with NDK. Let's first start off with its definition. So basically, what is NDK? By definition, it stands for Native Development Kit. Basically, it means that we would be using C and C++ instead of Java to make our Android code. We would be seeing what we have advantages and disadvantages of using C++, but that's just going to come. And another thing, that is code once compile everywhere. Now, this means that we have to write the source code in C, but we have to compile it for different platforms. Each and every platform, even for platforms that are available on Android devices. So what I mean by platforms on Android devices is this. Okay, so basically Android devices support three kinds of platform. That's the ARM architecture, 86 architecture, or MIPS devices. Maximum of your devices are ARM. That's why the Android logo is on the ARM, because more than 90% of the market has ARM devices. Further, there are some 86 based devices and MIPS devices are very less in the market. So this 86 based devices have to be compiled, our source code has to be compiled separately for 86 based devices as well as for MIPS devices as well as for ARM devices. So let's see. Basically, two kinds of app can be made in Android. First is using the Dalvik VM. I would be explaining the Dalvik VM further, but basically if you make any Java app in your Android, it's based on Dalvik. And the other type is native apps. So what are these native apps? Basically they interact with Dalvik, but when that interaction finishes, the control is left onto the C++ code to interact with the environment of Linux or the hardware. Okay, so let's see what Dalvik VM does and how it's separate from your regular Java virtual machine. So that's something that everybody learns in college or something like that. That we write our source code, it's compiled into Java bytecode, and further that bytecode is interpreted into machine code. That's the regular flow of Java virtual machine. Now what Dalvik VM does is that this bytecode is further compiled into Dalvik bytecode. That has an extension of DES. So why this extra conversion? Because Dalvik has to run on Android devices that have very less memory as compared to your PCs. So Dalvik automatically does some kind of enhancements so that this code can support mobile devices as well. And then it is interpreted by the Dalvik VM. So this is the basic architecture of our Dalvik VM. Now Dalvik VM also interacts with the Linux kernel. How it does that is all the apps that we develop are basically encapsulated by the Dalvik VM. This Dalvik VM further interacts with the Linux kernel, which interacts with the hardware. So this kind of interaction is whole what goes into the Android virtual machine. Now, I would like to also ask from you that if I am talking about developing apps in NDK using C, C++, going out of the way, like we hear about Android, we always hear about Java programming. So why would we want to use C, C++ even? Kind of reason for that? Why would you prefer using C, C++ over Java in Android? Speed. That's a very good point. Speed. Any other reason?
Does it allow you to bypass some of the security built into Android? Like not needing root access for certain
Not meaning?
functions? Not needing root access?
Root access. Actually, you don't need root access, but then also Android imposes some restrictions. Obviously, you have the power of C, that is, you can use the pointers to access memory. So that's also a valid point. Okay, this was about the pros of using C. Somebody can think about the disadvantages of using C with Android. If anyone can guess something.
Maybe more difficult memory management.
That's true. That's totally a valid point. Great. Any other point that you can think of? Obviously, the responsibility of memory management would be in your hands, because in Java this is done by default. In C, you have to manage this. So let's see into the pros and cons. First of all, the advantages. Okay. The first thing is the performance gain, the speed, as my colleague Gaurav said. C++ code always actually gives you an increase in speed when you run complex algorithms or any logic that you have defined. Same logic that you run in Java, you can get an enhancement in speed using C. Plus, making something that uses GPU or your hardware acceleration, the animations are much more smoother and lag free in case of writing the code in C as compared to writing the code in Java. And for that performance enhancement, we would be showing you some benchmarks as well. Other thing is software code reuse. I would like to stress on this point of software code reuse. Like I have some library that's already made in C++, like some sound processing library. It requires to be rewritten into Java if I have to code my app into Android. Rather than doing that, I can use my C++ code as a library, make wrappers in Android that uses C++, and then I don't have to write that C++ code again. First advantage is this. Plus, this C code can also be used into iOS because iOS also supports directly using C or C++ code into the app. Then also, this code as a wrapper can be used with your Windows application and your Mac applications. So this is kind of software code reuse for all the platforms. You are writing your code in C++, and then the maintainability would be only on one code that is written in C++, and that code is only used by Android or your iOS or anything. So it goes like this. Now I would like to show you a diagram there. Actually, I can see many eyes like this in the crowd. Okay, so you are seeing this that okay, NDK has advantages. Can it have disadvantages as well? So that's the thing. So now talking about the disadvantages. Why not to use NDK or where not to use NDK? So it goes like that. Performance improvements are totally not guaranteed. If you can benchmark your code, you can write your code and then you can see if there is an improvement. Then there is an advantage of using NDK. Otherwise, not. Plus, most of the Android developers are good Java programmers, but they write their code very well. But is the same level of code writing in case of C++ by those programmers expected? Because you have more management of memory and everything in your hands in case when you are programming with C. That is also an extra responsibility on you. Okay, so Java and C++ interop, that means that Java has to include the required libraries so that Java can talk to C++ every time you call its method. Plus, it's somewhat harder to debug. You can use GDG, but it's somewhat harder to debug your C++ code in Java. So this is my favorite image. This is Spider-Man. You have a lot of power, but with that you have a lot of responsibility. Like writing code in C++, like David said, there is a need of memory management. Obviously, you can use boost libraries and such to manage your memory in C also, but as it is, you have the access to pointers. You know that if you have allocated some memory or some resource in your app, you will have to create yourself. Otherwise, your app would be consuming more memory and sometimes would be shut off by the Android virtual machine if you don't manage the memory. So you have the power that you can allocate memory anywhere in the app, but you have to manage the memory as well. Now further, we would be looking at how basically the NDK works, compile, and how we would be getting into the code, and we would be seeing how we debug, how we make this app, and that would be introduced by Ankur. Okay.
So, thanks, Raman. Thanks so much for the very brief and good introduction about the NDK. So now let's make it to the work. Now, now the thing is like within this session, we'll be giving you a brief demo app, which will be like having a bubble sort algorithm, right? We have developed two instances of bubble sort. One is using a C implementations, one is using the Java implementation. So we'll be like making a run to both of these things simultaneously, and we'll figure out like how much time C takes and how much time Java takes. So right, so let's see how we do it. Okay, now think it from this perspective. Suppose you have written some function, a bubble sort function, which is simply taking your array and returning you to something like, to say, a time to calculate the sorting the function, right? So this is simply a function which I have written in C, right? Now to make a call to this function, because we'll be using Android apps, and Android apps are using like SDK, which is mainly Java. So this is a sample function which is written in C. Now how to make these things communicate with each other? I mean, how will be like calling C through our Java code, right? So let's see what's this. We make our code in C++, right? And we have a make file. So what exactly is this make file? This is nothing complex. This is just have you ever like heard of Maven? It's a build tool, simply a build tool. We just simplify, we just provide the inputs, like these are the files which we need to compile and make a build for it, right? So similarly, in this case, we'll be like providing set of the C++ files, like which we want to compile and make use in our Android app, right? So then we'll be using NDK build command to build this process for us. And after NDK build, we'll get some binaries, right, which will be like imported into our Android project, right? Then after we have the libraries, binary files in our libraries for Android project, we'll be simply making Java calls, right? So this Java call won't be like making a simple Java call to your other Java files. So this is something extra over here, right? Let's see how we do it. So suppose this is our Android application. For now, normal Java-based Android application, we make use of SDK APIs and make a call to Java framework. But in case of native things, which we have written over here in C++ code, we make use of GNI, right? So this is Java naming interface, native interface, sorry. So just have a look over this. So this is our basic activity. I mean to say this is simply a main activity.java file, right? So this is how we create a normal activity, or you can call it a window in Java. I mean Android app, right? We have extended this. This is an inbuilt class which we get in Android SDK to create our activity or windows, right? And these two lines are very much important in the main course of native callings. So first, this is our library which we have like already developed, right? And this is the name of our library. Now we are loading this library. This is a native C library. First, we have to load it, right? Then we have a declaration of a function over here. Suppose this is a bubble sort function. This is like having an input with the arrays which we want to sort, and this is like returning us a long, which is a like primitive data type of Java. And now have a look at this native keyword. Anybody heard of this native keyword before in Java development? Anyone? So this is like an extra keyword available in Java library when we like want to make call to our native libraries other than Java code, right? So this is just a declaration over here, but the definition of this function will be inside your C code, right? So this is the thing. Now there is one more thing over here. It won't be like we will be like making direct calls from Java to C code. There will be something, a bridge or a tunnel in between these two things. So this is a wrapper which is like making the work of this. Right? So simply create this wrapper, we have a Java H command available with us. We just have to tell this command whether this is the proper file where we have declared all our native functions, right? And please create us a native wrapper for us. So this is what this command is doing. This command is having an input file, which is our main activity, right? This is an input, and this is my required output file, right? After executing this command, it will create this file for me, which is called bubble-wrapper.h. So this is a file which I will be getting after executing Java H command. Now just have a look over this thing. This is simply a wrapper function which will be automatically created by Java H command. If you like especially analyze it with the native declaration which we have done in Java, so it's the same thing. It's the name, it's the activity, right? And over here it's returning a JLong. So this is like a symbolic return type for Java, right? In Java we have long, but in native wrappers we'll be having JLong, right? And this is again the input parameter, same input parameter. From over there we were passing int array. So over here we are having jint array. So now this was the wrapper. Now, so this was basically a wrapper, or we can call it a header file in C, right? So for this header file, we'll be having an implementation file, which will be like bubble-wrapper.c, C++, whatever you want, whatever the thing you want to implement it with C or C++. So what you do is like over there you will write up the code for the behavior of this command NDK build, right? And this NDK build command will do this compilation process for this, and it will be like creating different libraries, I mean binaries corresponding to different platforms, which Raman must have discussed just a few minutes back. AD6, MIPS, ARM, right? These are the different SO files. I mean, these are the like binary files just for us. So we'll be simply placing. Okay, so we'll be placing these SO files in the list folder of a normal Android project, right? So this is all about the things. So now we'll be like showcasing two apps with over here. First is we'll have a simple benchmark app, which is a bubble sort app, which I just discussed about it. And the next app is like we have another sound effects app. We are making use of a third-party library, which is like already implemented in C and C++. This library is simply like for giving the sound effects. You input a normal WAV file or MP3 file, and you apply the presets to it and get the desired output on the sound files, right? So this is a bubble sort application, right? So on the click of this function, it will make call to two bubble sort implementations. One is your Java implementation, and another one is C++. So let's see what the result it shows. So over here, we're like showing like how much time is Java taking and how much time is C taking. So like Java is around 1.6 seconds. So this is like a microsecond, and C is near about 0.9 seconds, right? So it's almost twice efficiency. So now let's have a walkthrough over the code. We open the main activity. So this is again the same main activity, right? Which is simply a window having a button, right? What it's doing is I have a loading of the library, then I have a declaration for my native function, right? And then when I execute the Java H command, it will give me this wrapper, bubble wrapper, right? So this is a wrapper declaration, and all this code will be like provided by Java H command only. I don't have to do anything it. It simply parses my main activity file and it like locates for the native keywords inside it. And corresponding to each native function declaration, it will create my wrapper functions over here automatically. I don't have to do this thing, bubble wrapper. And then I have my implementation file, right? So over here, I have included my header file, and now this is my implementation over here, right? So this is all C code, and let's have a look over the make file, which is like making the things. So over here, I have specified the module name, which I was like using over there, system.load library. So this is the name of the module, and this is my source file, which it has to like compile, right? Okay, so this was all about the bubble sort app. Now we have the benchmark app with us, which is like a sound effects app.
Sure. Can you also show the implementation of the function?
Yes.
The C implementation.
Yes, this was the C implementation.
Can you just walk us through what did it do?
Okay, so this is the implementation of bubble sort in C. We have a same implementation of bubble sort in Java also. To benchmark it, we have given it even the same parameters. The same array has been passed into Java, and the same kind of array has been passed into C. So we get an input of the array as an argument, because that array is passed from is passed into the arguments here. J array, it's basically an integer array, the Java integer array. A Java integer array is passed from Java into C. Now let's look at the implementation. We get the length of the array as well as the input array here, and then we implement the bubble sort algorithm. The same kind of implementation has been done in Java, and it's the same code. And then what it does is that it computes the time difference between the start of the loop and at the end of the loop. This means just the core logic, how much time the core logic takes. Also, we have right now taken the input length as 5000. We have sorted 5000 elements, and we have made it the worst case complexity, that is n square, and we have taken the n square complexity for our array. That is, we have arranged the elements of the array into descending order from 4999 to 1 to 0. So in this case, we have implemented the algorithm, and in Java, this is the same kind of implement. This is the same kind of implementation. There, totally the same implementation, and we have calculated the t start and t end here, and we have got out the time in microseconds, whatever time is, and have returned it. It's kind of the same functions being implemented in C and Java, and then also the time difference is about double. This means C is getting twice as fast result for 5000 elements. We did this test for 10,000 elements as well, and we were getting 4 times of the difference. This means as the complexity increases, as your input length increases, C performs much better than Java in case of Android. So this is how this happens. Plus, I would like to show you a sound effects app. Now this is an app that we made. Carefully listen to this sound. This is an original soundtrack, and we would be modifying it further by using C libraries. Okay. So So we applied a lot of effects over this sound in C that requires real time manipulation of the sound, and that would not have been possible in Java because the calls with Java to audio API are really time consuming. So to do real time effects in Java, we used NDK. Okay, so let's look a little bit into the code of this app as well. This app has a major difference from the C++ app that we showed you in case of bubble sort, because in bubble sort we just encapsulate a function of C and then make a wrapper for that C function to call it from Java. But in this app, we have just told the app that your whole control is in C. We have written an Android main in C. That means the Java app would not be invoked using Java, but it would be invoked using C. So we have to do some manipulations for that. In our Android XML, Android manifest XML, that's the main file that specifies our configuration in XML, that how the app will be run and what are the permissions for the app. So first thing is that we have to tell it that Android has code false. This means it does not have any Java code. Our app does not have any Java code. It would be directly invoked from C. Plus, we have to pass in some values that were passed in our app from Java code. In the previous app, we passed this value from Java code, the name of the library, Android value. In the previous app, you must have seen bubble sort, the name of the library. Here, the name of the library is Little Indian Demo. So this name has been passed from the XML into C, that which library has to be invoked. Okay. So these are the changes due to which our directly instead of calling Android, our C++ file was called. And let's see into the C++ file how it handles which function is invoked. Because here in the Android manifest we haven't specified any function to be invoked. So this is the Android main function. Like any C++ file, when we run it on Linux or on Windows or on Mac, the main function is invoked always. In case of Android, we have to write an Android main function. If we tell that the app will be directly invoked from C++ code, our Java virtual machine or our Javalik virtual machine would look for an Android main function. So this Android main function is invoked, and then we have called sleep function because this app required some prerequisites, so some dependencies that would be loaded in this time, and then we have applied all the effects, and that's how the app runs. It would always search for the Android main function and then. So these were kind of the two demos that we wanted to show you, and both had some differences. One was invoked from Java code, just the method, and this is all the app written in C++, invoked from Java just to call the Android main function. So all the controllers.
What would give the UI to this app?
You could use OpenGL or any library that you want to use. You could use Unity also. So the basic thing is, if you have to make some GUI app, some app that like a game, you have to make a game that has a lot of 3D manipulation, and you have to make those manipulations really animated and lag free. You will have to use NDK because that's what done in the industry. Even an app like Skype uses NDK in its code most probably because of management. Like you don't have to write code again for iOS, again for Android. So for code management, NDK can be used. Plus for making animations, like making your OpenGL games, you can use NDK. So this was basically about the two apps that we presented to you, and now we are open for questions. Any question, any sort of question on NDK?
Basically, it's libraries delivering C.
Yeah.
You could one emulate sound effects.
Yeah. Yeah.
So if some library is available in C, I want to use it through my Android application.
Yeah.
And in that case, I have to use NDK.
Yeah.
Yes.
That's the way to use your C++. Okay, so Prashant's question was that he wants to use any library, if he wants to use any library that's written in C or C++ into Android, is NDK the way to do it? So yes,
Yes.
Prashant, you have to use NDK, you have to use C++ code into your Android.
Are there any security concerns?
Actually, Android, the major concern with C++ applications like what we get in Windows is that if you have the access to memory, you would be able to use a pointer and go to any space in the memory. But as Linux also does it, and Android also manages this thing, Android manages the memory space given to the application.
Actually, Android provides you a playground area within which your app can play. Out of the box, you can't target the Android's memory space. So it's only the capable RAM you have within your app, which is like available for your app only. You can play around it all.
If you would try to access your space, that's just the OS space in the memory, the space occupied by your operating system in the memory, the app would crash because Android manages the app.
Apart from this, if you like want to have access to your SD card or internal storage, then again you have to provide the permissions, specify the permissions in your Android manifest file. Otherwise, you will get a runtime error in your NDK or C++.
And the app will crash. That's it.
But if you like handle the error, it won't crash.
Yeah, but then it won't open the SD card.
Yeah.
So that's the difference.
On the newer version of Android,
Android has
4.4?
right, it doesn't allow write access to the SD card from other apps anymore, right?
KitKat?
Yeah.
KitKat allows it. Okay. So the question asked by David was that the newer version of Android, if I can get it right, the newer version of Android does not let you access the SD card?
Doesn't allow write access.
write access.
Write access. It allows you write access. You have to give a permission.
Permissions.
In user permissions, you have to specify a permission that
Read write access.
write access to the external storage, and then you can write to it.
Have you seen that person?
Yeah. I thought it might have been changed.
It could be a topic of.
No, but I have developed an app on 4.4.2, and it was letting me write to my SD card.
Even the same
With the
app
same
which we are
permissions.
doing for sound
Sound
effects,
manipulations.
it's like giving us an output file which we are writing on the SD card.
So 4.4.2 allows it.
Okay.
That's the image that I have. And further, if we were talking about Dalvik here, so the next runtime compiler for Android is going to be launched in Android L. That's called Android
ART.
Runtime, ART, and it would be replacing Dalvik totally.
Totally.
It has some more enhancements so that your memory resources are very less used, and plus you have performance gains by writing the same code. Any other questions, guys? Boys and girls?
This is the nicest audience ever. So, thank you, Ankur. Thank you, Raman. And I hope you guys all enjoyed, and all the people who joined us online, they also enjoyed. So, thank you again.